Hi everyone and welcome back to the multiverse of 100 plus data science project series. In this video, I am going to discuss about the potato disease classifications using convolutional neural network. So without wasting our time, let us start the tutorial right now. In order to creating here the potato disease classification project, we are going to use the dataset from the Kaggle that's called the plant beliefs dataset. And if I go inside my data explorer sections, you can see here it having several types of disease, just like the apples, the corn, whatever, right? We're going to using here the potato from here. Okay, you can see potato is also available, right? So what I'm going to do, I am simply going to download the dataset from here by clicking this button, and I'm going to starting here the coding part. Well, so we download the dataset from the Kaggle, and after starting the zip file, this zip file we got here plant beliefs dataset. If I go inside this folder, we have three folder: color, grayscale, as well as segmented. And if I go inside this color, and we have several types of folder. So what I'm going to do, we're just going to select here the potato because we're going to working on the potato disease. So that's why I'm going to selecting here this one, these ones. Potato early blight, potato healthy, potato the late blight. This is nothing but my classes that I'm going to working on that. So what I'm going to do, I'm just copy this out, and after that I'm going to creating here a new folder called dataset, and inside this dataset folder I just simply passed all of the folder. So inside this folder I have all of the images that you can see, and if I open this out, and you can see the folder, okay, in the images. Here we go. Okay, fine. And as well as I'm creating here an empty IPM file that's called potato disease classification.ipm file. And for this case, you're going to using here the Jupyter notebook. So without any wasting time, just go on the notebook right now. Well, so now it's time to make your hand dirty and try to do the coding part here. So first thing first, I'm going to importing here the TensorFlow. So let's import it here. Let's say import TensorFlow as TF. And after that, I'm going to import from TensorFlow.keras. I'm going to import in here the models and as well as the layers. So it not should be dot, it should be comma. So see, first you're importing the TensorFlow as TF, then as well as importing the models and the layer. So why this models and layer? Because we are working on the image data. I mean image classification types of tasks. So that's why we need to using the CNN. I mean convolutional neural network architecture. So which one is really best types of machine learning or sorry deep learning architectures, which one used to classify the images. And as well as I'm going to import in here matplotlib dot pyplot as PLT so that you can visualize the images, because using matplotlib you can also visualize the images, right? You can also using the OpenCV as well. Shift enter, and now you can see it gave me some kind of warning. So because I'm going to using here the Python 3.8.5, if I open my terminal, I mean my CMD, and if I type here the Python, so let's say Python, and then you can see I'm going to using here the Python 3.8.5. That's my version, that's my Python version, right? And then if I am trying to importing here, let's say import TensorFlow as TF, and then it also imported here. Now let's checking the version what I'm going to using here. Which version of TensorFlow I'm going to using it here, right? So let's say TF dot underscore version, and that's my version Python 2.9.2. It's my TensorFlow version. Okay, so this version I'm going to using here. Let's import keras as well so that you can also know about the keras version. So let's say keras dot underscore version. That's my keras version 2.9.0. That's my keras version, right? Well, so now let's close it. And now you can also using here another enter, and it will removing this warning. You can also using here the import warning. So let's say import warnings, and you can as well as the filter the warnings. Let's say filter warnings, and you can simply ignore it, just like that. Okay, you can also use this ones if you're using up-to-date version of Pythons. You can use that. So see, for I mean loading the dataset from a directory. So what I can do, we can using here globe. So let's import globe. We can also as well as using here the OS. You can use the globe as well as the OS. You can do that. So, but for this case, I'm going to using here the TensorFlow for loading the dataset from a directory. Yeah, because using the OS and the globe in multiple time in my YouTube channel video, there are so many projects are based on the CNN as well as the deep learning. So I'm going to using here the globe and OS for loading the dataset from the directory. So for this case, I'm going to using the first time TensorFlow. So let's say tf.keras.preprocessing.image data set, then from directory. Okay, see tf.keras.preprocessing.image dataset from directory. Now inside that, I'm giving here the path. So which path? Which path? If I go on here, you can see this is my path data set, right? So I need to giving here my path. So data set. Okay, and what I can do, I can giving here shuffle equal to true, shuffle equal to true, and then I can giving here my image size. So image size. Okay, so let's creating here some constant. So let's say image size. Oh, image underscore size. That's a 256. Then let's give it here the batch size. I mean, how many images of the batches is coming up here? I mean, how many images should be loaded in a one time in a batches? So let's give here batch size is nothing but 32. So let's epochs. Let's say, okay, let's make it blank right now, and we can make it path like that. As well as let's comment this line. We are going to actually initial letter, but let's give it here channels equal to 3 channels. So channels is nothing but for RGB images because we're using here the RGB images, I mean color images. So for this case, you can using here channel is equal to 3. If you are using here the grayscale images from our data set, if I go inside this folder, you have another folder called grayscale. You can also use this one. So for this case, I mean, your channel should be one. In grayscale image, just having one channel. But if you're using RGB images, so you have 3 channels, R, G, and B. Cool. So now what I can do, we can using here this image size and as well as the base size here. So we can back it out here and let's making it out. So we have the image size. Okay, it should be the image size, comma image size. You need to give it in a tuple, and then we can give in here the base size. So it should be base underscore size equal to that should be the base size. Okay. Now let's define into a folder called dataset and try to load it from here. Okay, so you can see here it found 2152 files belonging to the 3 classes. I mean, it having 3 classes. We're working on that. So you can also check this out, which is the classes, which one is the classes. Okay, so let's say dataset dot class underscore names, and you can store it inside a variable called, let's say, class name, like that. So if I try to print it out, you can as well as print on here, let's say class name, and you can see you have 3 classes: potato early blight, potato late blight, and the potato healthy. So those are the classes you're going to working on that, right? So now let's check here one of the images from here. So let's try to creating here a iterator. So let's say for image batch, and as well the labels batch in data set. Let's take first one, just take one images, I mean one batches, because see we have sat here the 32 batches. I mean in each of time it will loading here 32 images, right? Just checking this one, is it working fine or not? So let's try to print it here. That's the image batch. Oh, this should underscore, and let's try to first check the shape. Okay, just check the shape, and after that let's try to printing here the labels batch. Let's make it convert into numpy. Well, so you can see the first one, the batch number, how many batch of the images. So 32 batch, we give it here 32 batch of the images. I mean 32 images is nothing but number of images with height and number of channels, and number of channels item 3, you can say. And this is the images, it's loading from here in a batch format. You can say 111 000 1100 like that. We can also see the 2, I hope so. Let's run it again, and you can see 2 as well. That's mean it converting this into 0, is this one to the 1, this one to the 2. Okay, in a level encoded format, it will do automatically this TensorFlow. So you can see, yeah, load image is loading correctly. Now what I can do, because the first element of the batch is 32. I mean, 32 element of the images is uh, loading. Okay, that's the second batch. The second batch is coming. I mean, second batch of the email is coming. It's obviously 32. It's obviously 32. So how can I show that? We can also visualize it. So let's say visualize some of the images, okay, from our data set. We can do that. You can using here the hey each tag is tag or whatever, okay, and you can go on the markdown and you can use it here like that. Okay, so visualize some of the images from our data set. So let's try to visualize. So we can using here the PL data figure, then we can giving here the fixed size. थोड़ा साउंड बाहर से आ रहा है क्योंकि मॉम चिकन पे सॉरी किचन पे है इसलिए so image batch then we have the label batch in data set dot tick. Each batch is having the 32 images, so we can taking let's say 12 images and show it uh, in the images file. Okay, so what I can do, we can take 12 images. Let's say are in range, take 12 images. So let's 12, and then we can using a pld dot subplot, and in the each plot what I can do, you can giving a 3 into 4 is 12 and I plus 1, because one of the images should be coming up, and that's our axis. So it's axis, and then what I can do, we can using a plt dot im show, we can giving here image batch of the eye, which is coming up here, and we can convert to the numpy, and as well as we can convert them into the UINT8 unsigned integer 8-bit, fine, and we show it out. Now we can giving her title. Okay, it's not compulsory to giving her title, but it's best practice to give it here. Okay, let's say class name, because we have the class name as well, this variable, and from the class name we're going to taking here based from my levels. Why levels? See, because we got here some levels 0 1 2 like that. So just get here levels, and from the levels of the batch we're taking to the I. Okay, and we can making the axis should be off. Let's axis, let's making it off. Well, and it's loading the images, I hope so. Yeah, cool. And you can see images, and you can see potato early blight, potato late blight, the potato healthy, whatever, right? You can see 12 images. You can use it in your thesis paper or in the presentation, whatever, you can do that, right? Now that's our data set is ready right now. So what I can do, we can split the data set. Split the data set. Split the data set. In how we can have the training, then you have the validation, and then we have the testing. I mean, train, test, and validation like that. Okay. So we have the training. We need to have the training data. We have to need the validation data, testing data as well. You can also using here this kind of way. Let's say H, and using here the H. You can also bolt it out. You can using here B in the Jupyter notebook, and you can go on the markdown, and you can use it here. It's the data set, training, validation, the testing. So see, we have the data set, right? We have the full data set, which one is not divided, just having the images in each of the folder. So what I can do, we need to bifurcate it into three subset. I mean, divide into three subset. So now what I can do, first checking the length of the data set, length of the data set. So the length of the data set is nothing but 68. 68. Why 68? Why 68? Because it is loading the images in a batch format. Loading the image in the batch format. Let's try to test it out. So let's say 68 into 32. Oh, it will be 68. Say 2176. If I go up, okay, to 2152. Okay, and some of the images is not here. Some of the images is not here in the same batch. In the last page, which one is created, maybe having some low images. Sorry, having some images missing. So that's why. That's when it's loading the images in the form of the batch. So what I can do, we can do for the 80% for the training, 10% for the validations, and 10% for the testing, right? So let's try to do this out. Let's say train underscore size equal to, let's say, 0.8%. And then we can do it how? We can uh, multiply with the train size, then we have the 54.40. I mean, this is the batches or the length of the data set we can take it for the training. We can taking it for the training. Now let's taking this 54. Let's taking the 54. And let's say we can using here data set dot take, and inside that we can giving here the 54, right? So that's our train ds. So let's say train underscore ds. Well, and then we can tagging this on. Let's say length of the train ds. Well, 54. 54, cool. So taking it out and store it inside the train ds. Now what about the test? So we can taking it for the data set as well, and we can skip it. So let's try to skip it. And inside that, I mean, the full data set we have the 68. So rest of them we can skip it. I mean, let's say we can finish the 54. The rest of them should be in the go on the test file. So you can give it here the 54. You can give it here the 54, right? And that's our test ds. So that's our test ds. Okay, so you can also calculate the length of it. So let's say, sorry, test ds, not take ds. ds. Okay, 14, 14, 14. Cool. Now, if we're taking this validation for, let's say, see, we're actually creating here train size should be the 80%, test size should be the 20%. Now, if I'm taking the 10% from this test data set, 10% from this test data set, what should be that? 10% from the test data set. I mean, how are you creating you're explaining your data set? You need to first taking here the 80% for the training, 20% for the testing, and from the 20% into taking the 10% for the validations. So let's say bell size. So let's say bell size. Okay, bell size, let's say 0.1. Okay, now let's say length is nothing but, let's say, bell length of the data set. Okay, data set into bell size, I mean validation size. You can say 6. You can see the 6. You can see the 6. That means this is the validation size. This is the validation size. So now what I can do, we can taking it from the test data. We can take in the test data. So let's say test ds dot take how many? 6. 6. That's our validation ds. So let's say bell underscore ds. And if we calculate these ones, so let's say length of the bell ds, you can see 6. You can see the 6. Now what about the test ds? So let's say test ds is equal to, let's say, test ds dot skip how many? 6. 6. Now let's calculate the length of that test ds. 8. 8 for the testing and 6 for the validations and 54 for the training size. समझ आए आप? समझ आया कैसे इसको ब्रेक करता है? Now what I can do is simply going to creating here a method, so which can actually help us to divide our data set. To divide our data set. Okay, it's nothing but the theoretical part. Theoretical part. Okay. So let's say def. Let's say get us data set. मैं थोड़ा theoretical. I mean, I like to teach you the theoretical part as well. So that's why. I mean, कैसे काम करता है? कैसे डेटा को आपको डिवाइड करना चाहिए? Some kind of cases in Kaggle you need to have. They actually give it to us. Train, they divide it as train, test and validations. In some case not. So you need to divide them. You need to divide them. आपको divide करना चाहिए. कैसे होता है divide? So now what I can do, we can pass in here my data set. Let's say ds. I mean my data set, and now inside the parameter we can giving here the train split. I mean my train size is split, let's say 0.8. By default, I'm going to give it here default parameters and give it here the validation split. So कितना चाहिए हमको? 0.1. Then test split कितना चाहिए? 0.1. Then we can giving here shuffle equal to true. Okay, shuffle equal to true, and you can also giving here your shuffle size. So let's say shuffle size Let's give it here 10,000. You can give any of them. Okay. So don't use it here because you're going to use here the Python, not C++. Okay. Now what I can do, first we're going to checking that the uh, the person is coming. I mean, the train is split, the validation is split, and the text is split. How I add them, it should be one. It should be one. We need to check them. I mean, what I'm talking like that. Let's say we have these three variables. Three variables. Let's say this one and this one. So let's remove the comma from here. I mean, when we join them, when you join them, this train split plus bell split plus test split, it should be equal to 1. Now you can see we got here true. We got here true. If I using here assert, and you can see our program is running without checking. It's checking this line. If it is working, then it don't give me error. I mean, your line is corrected. If let's say making it 2, let's making it do some changes on that. Let's say let's giving here 2, and you can see it will give me error, like assertion error. That's pretty strong. So how the user give me some non-valid data, non-valid or fake data. So what I can do, we can also check them. We can also give here error, sir, assertion error. You do this kind of error, this kind of task, right? So that's why you can use these ones. Just checking. That's what checking. You can also ignore this one. You can ignore this one. Now what I can do, let's say let's calculate the DS size. So let's say length of the DS. I mean the data set is coming up here. We need to also calculate the length of that. See, if I go up in the theoretical part, you can see we calculate the length first, right? So that's our DS size. DS size. Now what I can do now, if the shuffle is true, I mean आपको shuffle करना चाहिए और नहीं, shuffle करना चाहिए तो आप जा सकते हो, यहाँ पर जा सकते हो. You can shuffle it. Let's say ds equal to ds dot shuffle, and then you can giving here the shuffle size. Then you can giving a seat. Let's say giving seat equal to 42 or 12, whatever. You can do the shuffling. You can do the shuffling on the data. Then what I can do is do the same thing. Let's say train size equal to integer of train split into ds size. That you do here. You can see the test size, train size. You can see taking the 54, and you can also multiply it, right? So let's do the same thing for the test and the validations. So let's making it should be the bell size. Okay, and now we need to do the same thing for the test size as well, but we are going to take in this test size, taking the test size from the validation size. See, how can I do that? So you have the train size and the validation size, right? Validation split, it should be the validation split. So let me val split, and now to making the train ds should be the ds dot take. We can giving here our train size. Okay, now we're to getting here the validation size. Let's say val ds equal to ds dot skip the rest of them. Okay, let's say train size, and we're going to taking here the val size as well. Okay, so in the validation ds, we're simply going to skip here, skip this ones, and we're going to taking here our validation size. So what will be our test ds? So test ds should be like that same way. Oh, test ds should be the we can skip here the train size, and we can skip here the bell size as well. We can skip here the bell size as well, right? You can also split here this test split as well. Same thing. You can give it here. You can give it here. You can give it here the test split as well, because both of the things are same. 0.1, 0.1. You can also remove this one as well. Okay, so it's not needed. So our train ds, validation ds, test ds is ready. So you can simply going to return it here. So let's say return here the train DS, I mean train data set, the build data set, and the test data set. Okay, same. We're taking this one, DS will take the train size, and we're skipping here the train size, and we can taking this ones, and we can skip here. We can skip here. Okay, we can skip all of them. Rest of them should be the test data set, right? This kind of error can be happening. Again, see, we first taking the train size, and rest of them we're taking as the bal size, I mean our validation data set, and rest of them which one is available, we simply going to put it inside our test ts, inside our test ts. So now let's run it, and it's loaded. Now what I can do, you can using here, and then we can pass here my data set, and shuffle is by default true, and we can return here, it return here this one, and we can get here this trend ds, validation ds, and the test ds. And if I try to checking here the length of the trend ds, and then you can see the 54, and same thing, copy here the validation ds, you can see here the 6, and same thing if I using here the test ds, then you can see 8, same thing you can see here, same thing, right? Same thing. Just convert them into the functions. Okay. Now we have the test ds, the validation ds, and the test ds as well, right? Now what I can do, let's give it inside a cache, uh, so that our memory can be released, shuffle, and the prefetch. So fetch the data set. You can go on the TensorFlow website, and you can also know about that, what is catch file, what is the shuffling, and what is the prefetch. Okay, and go on the markdown and go on here. Here you go. Now what I can do, we can using here train ds equal to train ds dot catch file, and you can shuffle it. Let's shuffle it. Let's say 1000, and you can prefetch it. Prefetch, and then you can giving here our buffer size equal to tf dot data dot auto tune. Okay, not auto tune actually. So we copy this out, and we're gonna simply pass it here two times, and to change in this one, should the baldius, oh, baldius, the test ts, and you can changing this one as well. Oh, test ts and test ts, right? And now what I can do, let's run it. Well, it's running fine. Now it's time to build in the model. It's time to building the model, I mean our architectures. But before actually creating the model, we need to also resize our data, right? We need to resize our data, and as well as normalize our data. What is resizing actually? See, we give here 256. I mean, all of the images in the CNN should be go in the same size. Should be go in the same size, in the same base. And it's better we can normalize our data. We can normalize our data. It should be better. So what I can do now, we can normalize our data. So let's say data resizing, sizing, and normalization. Normalization. Okay, let's go on the markdown, and here. Now for resizing and the rescaling, so what I can do, it's a resize and rescale. We can simply using here the tf dot caros dot sequential. See, in every cases, how you using sequential, we're using here model file. I mean, we're creating here the model. Uh, so you actually, how you actually using the sequential for creating the model. Every time you're using the sequential for creating the models. But this case, we're going to using here the sequential for resizing, and as well as the normalization. So for that, we're going to using the layers. So from the layers dot experimental, okay, dot preprocessing, dot resizing, and you're going to using here the image size that actually getting here, and the image size, so image size, right? And then what I can do, we can also give it here uh, the same thing, experimental dot pre-processing dot rescaling scaling, and we can giving here 1.0 to 255. So why 255? Because the maximum number of the images should be go on the 255. Okay, and a minimum should be one. Minimum should be one or zero, whatever, right? So if I run in this one and our resizing and the rescaling is created, now we can do the one thing again. Let's call the data augmentation. Let's call the data augmentation. Let's say data augmentation. Okay, let's go on here and do the markdown. Okay, so that's what data augmentation. So for data augmentation is needed when we have less data. So actually this boosts the accuracy of our model for by augmenting the data. That's why you're going to using the data augmentations. So using data augmentation, you can generate some images. You can generate some images using some flip, just like horizontal flip or zooming or sharing, like just like that. So what I can do, let's getting here a variable called data augmentation, and then we can using here the same thing. Let's say tf dot keros dot sequential, and inside that we can using here, let's say layers, same thing, experimental dot pre-processing dot random flip, and you can giving here the flip type should be the horizontal and a vertical flip. So let's say vertical flip. Okay, vertical flip. You can also giving here so many of them. You can go on the documentation for the TensorFlow, and you can giving here the some kind of argumentations technique you can using here. Let's say experimental dot preprocessing dot, you can giving here the random rotations. So that's a random, you can giving here the rotation, that's a 0.2, 20% of the rotations. Okay, now our data augmentation is as well as ready. So now let's apply it in our trained data, not test and the validations, because this is testing. This is for the testing. So we can apply it in our trained data. That's a train ds dot map, and we can using the lambda functions and remeth functions. That's x comma y because it have two things, and we have, let's say, data augmentation. Okay, and you can give it to the x and the training training equal to true, and let's passing here y as well. Okay, because this is the array functions, right? Now inside that, what I can do, we can, it should be training equal to true, it should be not there, it should be here. Now we can using the prepath, and we can give it here buffer size. So buffer size equal to tf dot data dot auto tune. Okay, that's our train ds. Okay, and you can see prepared data set is ready, and tensor is ready as well. So let's put it in the same folder. That's called train ds. Okay, it's ready. It's ready. Now it's time to creating here our architectures, or model architecture. Okay, let's say model architect, ARC, like that, architecture. Okay, architecture. Let's getting this ones. Go on the markdown. Okay, sorry, markdown, and that's our architectures. So let's first initialize here a variable called input shape. So which one is nothing but from batch size, and the image size is called the reshaping, right? Image size and number of channels. Okay, then we have the classes. So number of classes, Okay, it's nothing but three classes we have. Well, so now let's try to define here. So let's a model equal to models dot sequential sequential. Now let's get it here. Let's say layers dot con2d. Okay, but before that we have to put here the reshaping and rescaling as well. I mean resizing and the rescaling as well. So in here we can put it, and then oh, it's not a functions. And then inside here we need to giving some parameter. Let's give it here 32 the filter size and kernel size. Let's say kernel. Okay, kernel size. So let's say kernel size. Let's say give it here 3,3, and let's give it here activation. Let's give it here real activation functions, and then we can use them here the input shape is equal to input shape that you actually declare. Then we can add here same thing. Let's call we can add here the max pooling 2D, and here you go max pooling 2D, and you can using a 0.2, sorry 2,2. Okay, and then next layer you're going to add it here. Okay, and then I can give it here, let's say 64, and in this because this is not an input layer, so you can remove in this ones. Okay, see how I actually give it here this kind of value. Yeah, I can give it from a paper I am following. So in the paper they're actually writing this code like that, the architectures. So we are following this same strategy for creating these architectures. You can also give here some random value in the neurals, and you can test it out here. You can also using the net. You can use it here. It's custom. Okay, you need to research on that. You need to research on that. So let's copy these ones and let's try to paste here 5 times. So yeah, hope so it's ready right now. 5 times 1, 2, 3, 4, 5. Yeah. Then after that, what I can do? What I can do now? We are going to add in here the last flatten layer so that we can convert into a single vector, just a single vector, because this is the two-dimensional matrix. It's right now there, and when I actually apply here the flatten, it will convert into one single vector. Now this single vector should be pass it inside the dance layer. So let's say layers are dance, and you can pass in here the 62, 64, and we can using here the activation is equal to railway activation function, and then what I can do, we need to give in here comma, right? I'll give it a comma, 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 comma here. Oh, not there. Here and here and here and here and here. And this is boring text as well. And then we can add in here layers dot dance, the final layer. So it's nothing but the number of classes. So number of classes we can give it here. And because this is having 3 classes, it's not a binary classifications. So we can give in here activation equal to softmax. Okay, softmax. Well, and then that's our model is ready right now. Okay, it's ready. And then what I can do, you can simply build it out. That's a model dot build, and you can give here input shape. Let's say input shape equal to input shape, like that. Model is ready right now, and we can do the training. But before that, let's checking here summary of the model. And that's also summary of the model, how many parameters available, output shape, all of the things. You can get it here. Now it's time to compile our model first before training it out. So let's compile it. So we can using here optimizer is equal to, let's using the atom optimizer. Okay, then let's using the loss. So we can using here tf dot keras dot losses. We can using here the spurs. We can using a spurs categorical cross entropy, and from logits. Okay, from logits, what I can do, we can make it false. We don't need it, right? right? And then we can giving here the matrix equal to accuracy matrix, right? And now let's try to format it out. And then here we go. Now it's time to fitting our model. So let's giving here model dot fit, and inside that we can giving here our train ds, train underscore ds. Then what do you have? We have the epochs. So epochs. Let's give here 10 epochs, and you gain here batch size. Let's giving here the batch size, the same batch size. I mean 32. And then we need to using the verbose. Just you're going to see the training epochs. Then we can giving here my validation data. Validation data is equal to val underscore ds. Let's make it inside a variable called history so that you can see the accuracy losses as well. I can and also try to plotting it out. Now let's run it here. Now you can see our epoch is ready started, and when it's completed, and I'll back right after, and we can do the testing part here, as well as the we can check in the accuracy in the graph as well. So yeah, I'll back right after when the this model compilation is done, I mean training is done. Okay. And well, and our model training is completed, and we got here 93% accuracy in the testing data, and validation accuracy got here the 94%. Okay, so it's not the testing data, it's the training data. In the training data, you got here 93% accuracy, and for the validations, we got here 94% accuracy. Quite good, quite good. Now let's try to evaluate our model. So let's say model dot evaluate. Okay, evaluate should be like that, evaluate. And now we simply go to evaluate our test data. So let's say test yes. So, and let's assign to the variable called scores. So let's say scores. Okay, and here we can get here the losses and as well as the accuracy. And then you can see it's testing it out in our 8 batches, and it got a loss 25%, I mean 0.25, and accuracy is 90%. I mean, quite good. We got here 90% accuracy on the test data. Quite good. You can also increase your epoch size, and you can also get your better accuracy as well. Now what you can do, if I checking here the scores, and then you can see this is one list which one having the losses and as well as the accuracy, right? Now what you can do, we can also creating here one graph. I mean, how our epoch size after increasing the epoch size, how the losses decreases and how the accuracy increases. You can also check this out. So let's try to first go on our history, and inside our history, let's taking the parameter. So let's say params. Okay, and you have the verbose equal to 1, epoch is 10, and a stop is nothing but 54 step. 54 step, why? Because our training dataset length is nothing but 54, right? So now let's checking for the key. So let's say history dot history history dot key, right? Okay, has no absolute call key, it should be the keys because it had the multiple, right? We have the loss, we can accuracy, validation loss, and the validation accuracy. So what I can do, we can simply go into plotting this out in our graph. But before that, let's start checking this type of that. So let's check in the type. Let's say history dot history, history, and let's getting here the loss. Yeah, it's a list. It's a list. So that's mean we can access the value from here. We can access the value from here. Okay. So let's try to check the length of that, length of the losses. I mean, how the length should we look like that? I think 10 because you're using the tiny epochs, right? I mean, tiny epochs. This is the length of the losses. Now, what you can do, we can simply go into creating here one plot, just creating here a plot, which can actually help us to show that how the accuracy increases and how the losses is decreases as well. Okay, so how can I get the accuracy from this history? We can get it simply like that. Let's say accuracy equal to, we can copy this out, just copy this out, and we get the accuracy. Let's say accuracy And for getting the validation accuracy, we can simply using the val add double cc as the variable name. Then we have the loss and val loss. How can I do that? We can copy this thing, just copy this thing and paste it here the multiple time. And after that, we can giving here the validation accuracy. It should be the val accuracy loss and the val loss. So val loss. Okay, now you can check here one by one. Let's say accuracy is the accuracy list for the 10 epochs. Validation accuracy, you can check this way. See, this is nothing but one list. This is nothing but one list. That's mean we can simply going to plot it in a graph. Okay, so let's try to plot it out. So what I can do, we can, let's say, visualize uh, loss and accuracy in graph. Let's say graph. Let's go on the markdown and let's make in markdown. Let's take some shell as well. Okay, let's try to creating here one figure first. So let's say figure, and we can giving here the fixed size, and inside there let's giving here one fixed size. Let's say 15,5 should be the best because I hit and trial this one. And then I'm going to using subplot. So we have the two plots, so that's why we're using here 1 comma 2 comma 1. Okay, subplot. And then we can giving here the plot. Let's say plt dot plot, and then we can using the range functions, and we can using here the epochs. Epoch should be the 10 epochs, and then you can give me the accuracy. Then label is nothing but my training accuracy, right? Training oh, accuracy, fine. And then we do the same thing for the validation accuracy as well. So what I can do, we can convert this accuracy into the val accuracy because we have this val accuracy as well. And then we can give it here, let's say validation accuracy, right? Now let's giving here one legend. So let's say plt dot legend, and inside that we can giving here a lock. So it should be the, let's say, lower right, the lower right side. And then we can giving here one title. We can giving here, let's say, training and validation accuracy. Well, and then we can copy this out and it will do the same thing for the loss, and this should be the two side, I mean this side, and it should be the upper right. Okay, is the lower right and the upper right, and it should be the training loss, and it should be the validation loss, and this accuracy should be converted into loss and the val loss, right? Tiny box, and shift enter. Now you can see how the accuracy increases. You can see increases and how the loss is decreases. Okay, is the training accuracy? Oh, it should be the loss. Okay, now fine. You can see how the loss is decreases. Cool, right? Now let's try to test it here in a single images from our data set. So let's try to importing here the numpy s and p. Then let's taking it for the batch. So let's image batch, and we have the label batch, labels batch, and let's taking one images from the test data. So let's say test ds.take. Let's take one of them. Okay, and try to predict it out. And which one is it? Let's say first image equal to, let's say, image batch, because it's the first image, so it should be the 0, and convert it to the numpy. Then you're going to making it as type issue with the uint8 that we do, as well as the model training file. And then you have the first level, first level of the images. So it should be the levels batch, of the zeroth dot numpy. Why this one? So that we can see the actual as well as the predicted level as well, right? So let's giving him a statement. Let's say first, okay, first, first image to predict, right? And then you can show the each one. Let's say plt.im show, and let's say first image, and then you're going to print it out. And let's say this is the actual level, and then what I can do, we can give it here class name of the first level, right? First level. And then we have the batch prediction equal to model dot predict the image batch. Okay, image batch. Then we're simply going to print it out that predicted level, it should be the class name of the np.argmax, taking the maximum one, and you can giving the batch predictions, the zeroth one. And you can see this the actual level is potato late blight, and predicted level also the potato late blight. It's really working fine. Cool. Well, so now let's try to creating here functions, so which can help us to do the predictions. You can also use these functions for creating the web applications, but this kind of cases, I mean, this project I am not going to building here the applications, I mean Flux applications. It's your homework, it's your homework uh, to build build a Flux Flux application for potato disease classification, and keep access on our Discord server. Discord server. It's your homework. It's your homework, right? So let's go on the markdown as well. Distance. Now let's define here a function, so which will help us to do the predictions. You can use this predict button, I mean predict functions to actually predicting here your uh, images as well. You can also using here the Gradio library for creating the application as well, right? So let's making it here model. It's your text. सब कुछ मैं कर दूंगा तो तुम क्या करोगे भाई, right? So model and the images, and let's convert image to the array. So let's say image to the array. Let's say tf dot keras dot preprocessing dot image to array, and inside that you can passing here an image. I mean this image is coming up here, and after that let's convert into image array, and then let's say tf dot expand dimensions, expand dimension, that's the image array, and then you can make it 0, right? And now what you can do is simply going to do the predictions equal to model dot predict, and you can giving here image to array, right? And then what I can do, we can, let's say we need to convert them image into the numpy array, because it's just passing into here. You can also convert them into the numpy, right, array. And after that we have the predicted class, predicted underscore class, and which one is nothing but the form class name dot np dot argmax, and I can giving here my prediction, and this is the first one. And now we have the confidence score, confidence equal to just a round, taking the round of that of the 100 into np dot argmax, and then you can giving here the prediction of the 0. That's taking the 2 round. Okay, and then we can simply going to return here the predicted plus and the confidence, right? Cool. So you have this method called predict method, so which can actually help us to do the predictions. You can also give it here the image name, I mean from your directory, and you can also do the predictions. You can also do the prediction, but let's better try to taking one, let's taking one batch of the images from our dataset, because we have the already dataset right now. We can use in this one, so let's try to use this one. That's a plt dot figure, and after that using here a fixed size equal to, let's say, 15 comma 15, and then we can do the same thing that we do on here, I mean for visualizing the images. We can copy this out, and you can go down, and we can do it here. So let's taking here 9 images in respect of the 12 images, just taking here from the test data. So it should be test ds, right? Taking the one, and we can do the same thing in the axis. So let's say axis equal to plt dot subplot, and we can give it here, let's say 3 comma 3 and 1 plus 1 I plus 1. Then using here plt dot im show, and you can show the images. So let's say images, I mean this image batch. So let's making it image, because this is not printed in my batches levels, and let's make it images, and inside images let's give it here I, and convert into the numpy, and then making it s type equal to, let's say, unsigned integer 8-bit. Fine. And then we can give it here the predicted class. So let's say predicted class equal to we can using here this predict method that we created, so which one actually give me predicted class, and as well the confidence, right? It also taking it out confidence predict, and you can passing here the model and as well as the image. Okay, that's image is coming up here, this image. Okay, let's give it here 1. You can give here her numpy here as well, or otherwise you can give it here numpy. Both of the things it will work, right? So now it's images, and then we have the actual class, so that you can show that like that, these like this ones, this actual level and the predicted level. So actual class, we can take it from the class name. So class name equal to labels from the I, and then we can giving here plt dot title, and then we can giving here, let's say actual is nothing but, let's say actual, and we can giving here, let's say actual. Okay, this actual images, so let's give it here on f string actual images, I mean actual class. So let's say actual class, and let's giving here one backslash n, and we can, let's say predicted, let's say predicted class. Okay, and you can also give it here the confidence. So that's the same thing, backslash n, and we can say the confidence, and you can show the confidence in like this way, confidence, that's a percentage, or this percent, this 100% confidence or 90% confidence, like that. And then you can using a plt dot axis should be off, let's off. Okay, syntax problem. Why 3 comma 3, yeah, this should be comma. Okay, image is not defined yet, this image is not defined yet. Why this subplot is image model image, this image is not defined yet, image to array, and okay, it's images, and it's image, so it should be images, I hope so, and this is the images as well. Now let's see, Yeah, it's working right now. And now you can see here the confidence is right now 0%. Potato early blight, confidence 100%. Potato late blight, okay, is 200% confidence. Okay, and late blight. Okay, yeah, it's working fine. It's working fine. You can see. Okay, that how it will actually work. This why this kind of error is happening here. 20%. Why it's show like that the 20% of the confidence score. Why 100 np dot arg max and would do the predictions. Oh shit, that's why we need to giving here two things. Np dot arg max. We can give it here on bracket as well. That's what is happening. Okay, now let's check it here again. Right now I hope so. Okay, you can see it 20 200% as well. Okay, no problem. Confidence is not mandatory as well, but yeah, you can see here it pretty well. Actual potato, the potato lead blight, this one, this one. Yeah, it's really working fine. It's really working fine, that you can see. You can add it in your thesis paper or whatever. You can use this, right? You can also use this method for actually creating here the web applications. In the Gradio, you can also using the Gradio library. You can using the Gradio library as well for creating the applications. Okay, you can just give it here the images and it will working like that, right? This method, same thing, same method, it will work. Okay, and it's your homework as well. Okay, homework. Okay, homework using the Gradio library as well as you can using the Streamlit and the Flux. Okay, and send the screenshot into our Discord server. Okay, it's your homework to do that, right? Homework. Okay, fine. So that's it for today now, and hope you enjoy this full tutorial. And in the next tutorial, I am trying to coming up with the another projects. Okay, so till then, take care and bye bye.